No, I'll come back. Let's just go back. If you know where it's a little bit of nowhere. Good.
I've never felt this paper before.
Well, you're talking about finish of the semester. Yeah. That's crazy. So much fun.
I don't know if it was now.
It's like now reality starts to set in, you know, like, monsters finish it all. Monsters finish it. I didn't even know this. I feel like obviously it's just a great time. It's officially supposed to. I think it's and then, like, you know what I mean? Like, there's no, I went with my people just like surround. I'm not sure. I think a friend of mine is like fundraising.
Just before we get started, I didn't realise that the lecture slides have not been put on Moodle, so there's a QR code here for you to navigate. So the EPT is there basically. Yeah. Alright.
We are too much.
As you would.
Also wirklich 112, 150 Also irgendwo hat es nicht
So just find this is where the lecture notes are, but the lecture slides are for anyone who didn't catch that. Sorry about them not being on Moodle before. Okay, I'm going to get started. let's get started. So, this is how the lecture is going to go today. It's going to be mainly about empirical work on valuation of biodiversity and effective policies for biodiversity conservation, right? So some of those issues there. Building on the kind of theoretical stuff that we did last week. So yeah, this is it. So part one was all about measurement and theory. Part two is about causal evidence, empirical evidence, value of biodiversity, efficacy of interventions, and so forth. However, I'm going to do a quick recap. Last week, what we did was, and you'll remember probably by heart now, these equations for measurement of different metrics for biodiversity. You've got the hill measures, you've got your alpha, beta, gamma, Weitzman's Noah's Ark principle here, extinction risk, and some kind of mixed metrics. You know, there's a lot going on there. There's lots of different ways that one can think about measuring this concept that we have in our head called biodiversity, which is sort of just the diversity of living things. So it's a concept, many related metrics. Now, of course, the choice of metric that you use is of consequence, right, in this, when we're interested in policy. Now, just to recap, this is the paper by Charlie Palmer and I and Lorenzo Silecci, who's a kind of visitor here at the department as well, is our PhD student before. So remember, we were looking at bird data, and our question in the paper that we wrote was really about like the effect of agricultural policy on biodiversity. So basically what happened was the European Union back in the 90s decided, for various reasons which were exogenous to biodiversity, that it wanted to cut the amount of cereal production across the European Union. So we basically had a centrally organised policy that said, right, every farm has to reduce its production of cereals by, 5, 10, 15%, and it changed over time, so you got some variation, right? So we use that variation coupled with the bird data for the UK. Remember our crazy bird people who went around every year counting up the birds and all of that, very helpful for us, time series of data. So we looked at that and we were trying to work out, what was the impact of removing all of this agricultural land from production on biodiversity. And we used abundance of birds. We used species richness, a number of different species. We used the Shannon index, that's one of the hill measures there as our outcome variable. We used like distinctiveness, this mixed measure HAED, which is kind of relative abundance with a kind of branch length taxonomic genetic distinctiveness thing wrapped in. And these are the effects. So two things you see about this is that, it depends on the measure that you use as to whether or not this policy had any effect on biodiversity. The kind of theory here is you remove agricultural production, intensive agricultural production. You remove that, and it's going to be good for biodiversity and birds and such like. So, yeah, okay, sometimes it is, and that's true for some measures like abundance and species richness, so species come into range, there's more of them, but these kind of pure diversity measures, they don't do anything for that. So, it's really important what we think is important. That's a really crummy sentence, isn't it? We need to be very careful about how we choose the metrics for biodiversity, because some of these things we might care about, some of these we may not care about. So, for instance, the reason why we don't get a Shannon impact here is I think, well, we know now actually, is because the abundance there is occurring. The increase in abundance is occurring in already abundant species, right? These generalists, these non-farm generalists, basically, is where the main impacts are happening. A few farm specialists as well, but in the main part, the abundance is happening where things are abundant already, right? So that doesn't do anything to your biodiversity measure, right? Because it doesn't really weigh things that are already abundant. In fact, they get a low weight in that measure. So. Okay, so that's really important to have some kind of, and by the way, just to let you know, we're very careful about our empirics here. What's the problem with using the same data set, like 5 different outcome variables or 4 different outcome variables? Yeah.
I mean, you would expect to have significant results just by chance.
Yeah, you could do, right? So you've got to be careful. You've got multiple hypotheses from the same data, right? You shouldn't be doing that without some kind of correction to your standard errors, and we do that here for all of them. But this is just for the abundance measure. Okay. All right. So, yeah, really important to understand which metric you're interested in and so on. We had some sense of why biodiversity might be important from a theoretical perspective, right? And we went through the Giglio paper, which is a really kind of interesting, actually it's like an economic model with the things relabeled to say species and ecosystem services rather than like firms and sectors and things like that. But it kind of makes sense with these substitution wrappers and the substitutability, the redundancy, etc. It was a really interesting perspective on why species are interesting to us via the ecosystem services that we get and the output that contributes to in the macroeconomy. Okay, so that's pretty helpful. We thought about risk, right? We thought about those values that we get from risk management, and we thought about innovation and how there's some value there. But it's not going to be the thing that tips us over into wholesale conservation of biodiversity. It's some serious kind of analytic, if you think about the way in which that problem takes place, sampling, the solution of different problems, the values really aren't that high or sustainable because once you've found your solution, there's a huge amount of redundancy in your samples. Okay, that's the idea. I'd love to hear your thought. Someone to come back on some other point on that. So on all of these things, I think there's a lot of empirical work to be done to establish exactly what it is we think is important about biodiversity, which of those measures we think are the most important. We've seen some, we saw the pollination stuff, there must have been quite a nice festival atmosphere for the biologists in the almond fields, counting up the insects, I think. I imagine that was quite a nice summery kind of springtime kind of activity, camaraderie between the biologists and how many insects did you find today, that sort of thing. That would have been fun. And it's an amazing bit of research, not published yet though. I don't know why they haven't done that. Stefan Baumgartner seems to have a problem sometimes finishing certain things off. But anyway, that was a really amazing study. There's a paper on the reading list by David Simpson, same David Simpson, which is looking at pollination as well, looking at how actually, again, like how valuable pollination can be to agriculture, particularly fruit trees and so on, in California. We've done some work, like the work we did was following on from like really the pioneers in this area, Jean-Paul Chavas and my friend Salvatore Di Falco, who I mentioned would have been sort of standing here 10 or so years ago. More, actually. One of the group of biodiversity economists that hang out and work in this area. But the work by myself and Francisco Fonts, just looking at like the Shannon index of cereals, of different crops actually in Ethiopia. Various different crops, and this is the yield, the mean yield on the y-axis here. So you see, as the diversity goes up, you've got an increase in the mean yields for these farmers, right? So you can do you've got some sense that biodiversity, diversity of crops, and so on is helping us out, helping people out on average there. Okay, but all of this, it's really important to be kind of quite realistic. If you're going to start making policy based on all of this, then you need to be really realistic about what these values actually are and like how important they are, these values. You don't want to be moving policy away from health and education and social care and all of that unless there's something kind of concrete that you can say about those values, I should say. Right.
Yeah, just curious if you remember by any chance, why do we see a dip at the end there? Yeah. The standard errors shoot up. Is that just because the sample decreases?
There's really zero data here, so you get to the end. Plus, this is a kind of kernel density estimate, and so you're getting towards the end here where you've got basically no data on the right-hand side here. You're sort of smoothing over these intervals, and then the bandwidth ends. There's no data, so just standard errors increase. Yeah. Don't read anything into that. But one thing I said before, like in our case, actually, if you read this paper, which is quite nice, it's quite a nice paper. This was a lot to do with composition. It wasn't to do with diversity per se. It was really like if you grew teff, seriously important crop in Ethiopia. I don't know if you go to these Ethiopian restaurants, you have that really nice bread that comes out with all the food on top. That stuff, it's made out of teff. It's a type of kind of cereal. very low yield, right? And so this result was really coming from farmers who grew teff plus something else, right? So it was this combination of stuff. So you've got to be really, the point is you've got to be really careful about extrapolating results or interpreting results about biodiversity and the values that they have, okay? So I feel I sound like a real kind of doubting Thomas about this, but I'm just sort of, yeah, that sort of is our job as academics a little bit, okay, to find where the decent empirical evidence is. So hopefully that's what we're going to do today, right? So let's think about some values of biodiversity, then the efficacy of interventions. First paper I want to talk to you about is about this vultures paper, right? It's called The Social Cost of Keystone Species Collapse, Evidence from the Decline of Vultures in India. Who's read the paper? Who's had a look at the paper? Yeah, okay, so that's good. So, framing here, you know, what we've done in the previous lecture is think about these different metrics of like pure diversity, you know, the kind of variation of species and trying to measure that in some way. Genetic distinctiveness, number of species, relative abundance, whatever it was, you know, like extinction risk, etc. This is really focusing in on the ecosystem service type relationship here, which is what many of you were sort of thinking about. Some of you mentioned in the last lecture, like, why aren't we thinking about this kind of this productive value, which Giglio et al. Were trying to model there. Okay, so that's where we're coming in here. Really thinking about ecosystem services, and in particular keystone species. Species which, if they disappear, they are the ones which cause that kind of tipping point in the Giglio paper. You know, there's a redundancy up to a point, and then at some point everything becomes vitally important for providing ecosystem services. If those species disappear, then the ecosystem services crash out. So that's the basic idea here. So it's the theory which led to this empirical result was kind of well understood. All right, so what happened here? So the research questions in this paper really were like, what is a good conservation strategy? I'm trying to sort of turn this way occasionally, by the way, instead of always this way. I feel that's egalitarian in some sense. What is a good conservation strategy here, and what's the cost of functional extinction? So this functional extinction is removal of species that provide these functions, these ecosystem functions. So the rationale here is like, we're really interested in finding out what is efficient conservation strategy here. The paper mentions the CVM. Does everyone know what CVM is? Contingent valuation. Have you all been taught about contingent valuation? Yeah. Okay. Well, what do you think about that? As a way of, yeah.
That there are very problems with contingent valuation, specifically all the biases, the cognitive, hypothetical biases, the design, and also the representative of the sample. Yeah.
Okay. So yeah, and else? Anything else?
The people doing the evaluation might not be fully aware of all the services that vultures are providing, and if they're unaware of that or they're uncertain about the benefits.
Is there anyone pro CVM in this room? Yeah, tell me.
I mean, there are certain values that can only be captured by contingent valuation, like non-use values.
Okay. So that is the kind of landscape here when it comes to the contingent valuation. Yeah, there are some deep problems with it, and particularly, I mean, think about the metrics of biodiversity we've just been through, right? It's actually difficult to get your head around them, and then connect that to an ecosystem service. Really, actually, you don't even know those connections in the Giglio paper there particularly well, even if you're an ecologist, you know. So it's really difficult. But we're in this kind of weird position where we need something as economists to get our hands on as a number. Yeah, so we kind of do it anyway. And so, like in a different environmental economics course, this biodiversity lecture would be sort of one contingent valuation study after another. Look, we did this, people think this, and like there's some amazing studies, but I'm not particularly interested in them, which is unlucky for you if you are. Yeah.
Also, I guess especially for biodiversity, it depends if it's relevant how people value biodiversity, or like what species they favour versus like a more objective.
Yeah, I think that's what Weitzman was trying to get away with. You know, that we had the U term with the D term there. The U term was the one he wanted to ignore, which is our sort of, oh, I like cuddly things and I don't like mosquitoes kind of preference, you know. Yeah. All right, so we're going to come back to this in a second, but like this is unreliable for valuation is the main point, and so we need something kind of more concrete empirically about it. We need causal evidence. We can't do RCTs on species, you know, removing ecosystem species, so or keystone species. So yeah, so we're kind of a bit stuck. So focus on keystone species. Good idea, because you know, if you can look at natural variation in keystone species, this is where you're probably going to get some connection between loss of species and some ecosystem services, because they might have this kind of catastrophic effect on the food chain or whatever it is. Okay, so that's what A.L. Frank is sort of doing here in this paper, right? And I think it's a great paper. Love this paper. And it's one of the few papers that gets published in like top 5 economics journals on biodiversity. So like it's, you know, and you can see how they do this. This is a basic story here. So back in the day, let me just see where we go after this. Yeah, this is the basic kind of causality idea that they want to get through here. It's like, focus on the keystone species. They have big effects. You could get estimates of impact on human well-being. Think about VSL, value of statistical life. Do you know what that is? Has anyone talked about that? I guess Cephii has, isn't he, in the context of the right? And then think about mechanisms, like why is this happening? So this is the mechanism. There was a diclofenac. Maybe some of you have taken this yourself. It's a kind of quite powerful painkiller. Yeah, but they use it for cattle in India. So the context is India, right? And a patent expires on this, and so you've got lots of generic diclofenac drugs that suddenly swamp the market. It becomes very cheap, and so farmers start using this much more. This is a basic argument. Turns out that is they use it much more for their cattle. And so those of you who read the paper, did you see why they do this? Why do they do this? Why do they use painkillers? Yeah.
Probably. Well, I was going to say because there was like a patent that expired.
No, yeah, okay. So that happens. Yeah. Why is this demand for the painkiller? What does this do? Does anybody know? No, I didn't know either, because you don't know from reading the paper why they actually do this. AL doesn't mention this at all. Anyway, it's for milk production, right? It's to improve milk production. So, anyhow, so they give the painkillers to the cows in much greater amounts than they did before, and more widespread. So farmers who couldn't use this before, they now use it. Turns out that this has compounds in it which are highly, highly toxic to vultures, right? And vultures go, and what they do, they're like the waste disposal units of the land. They go and eat up every single carcass you could imagine. They clean it down to the bone. Within like 20 minutes, they can clean up a carcass of a cow until it's just bones left, you know. And they've got this acid in their stomach, which basically is so strong, it just kills all of the pathogens from these rotting carcasses. Anyway, that goes through, the mechanism is like, once these vultures disappear, you end up with other things coming in, and then this has a public health effect at the end there, right? So we're going to go through this right now and see how they manage this. So it turns out that this shock caused a decline in vultures, an increase in dogs and rats who took over that job. That ecosystem niche was taken over by dogs and rats. That spread disease, infectious diseases, and ended up with an increase in child mortality in India, right? Other ways as well, carrying water pollution, etc. So they look through all of these different mechanisms to establish the impact of the loss of keystone species. Okay, so here's the data that they use, right? So let's think about diclofenac. They have they have loads of local district level data collected at the local. So the institutions on this level are quite good in India for collecting data, particularly veterinary use of diclofenac injections and so on. It may even be, I can't quite remember, but it may even be that this is organised, to some extent is organised by local government and so on. But anyhow, the data's at the district level. and they know where this happens, right? So they know quantities of this drug that's used. And you can see, like, over time here, this is when the generic was approved, the patent fell out. You've got use of diclofenac going up, and you've got a decline of reports of the decline in vultures. These are reports of the decline in vultures here, because that's important to make. Reports of decline in vultures here, and this is the this is anecdotal data on the numbers of vultures that people see out. Okay. Oh no, isn't. What am I talking about? It's the price. So it's the economic data, it's the price. Forget about it. Yeah, price of diclofenac. So it really just drops crazily, so it's much more available to people. Okay. So that's the diclofenac data. What about the vultures, right? So this is the biodiversity data here. And I've said in the previous lecture that biodiversity data is pretty rubbish, actually, in general, right? It is not the case, that, like I was saying in the previous slide, erroneously, that people counted up vultures. In fact, and I was sort of thinking to myself as I said it, I was like, really? They don't do that. I mean, you get anecdotal kind of, they don't have the kind of BTO, British Trust of Ornithologists, kind of repeated sample of vultures over time in India, right? They don't have that. So you don't have actual counts of colonies of vultures in India, right? So what you have is like range data. And this is like data which sort of draws a line on the map, yeah, and says, well, like vultures of this type and of this type, they like this area, this kind of habitat, and this kind of habitat. And yeah, we've seen them in these kind of corners, and so we draw a kind of a line around the extent of observed vulture or sort of occurrence. And this is our range map, okay? This is where we think they're going to be. Yeah, so that's the data that AR uses on this paper, right? And then what he does is he uses terciles of overlap between the range maps and location of cattle, right? And so that looks like this. So this is it. You've got like areas split up into 4 parts, suitability of vultures determined by range maps, and then livestock, suitability of livestock here. So the red areas are the places where you get both highly suitable for vultures of different types and high levels of cattle as well. So that's the place where you're going to get a high level of treatment. A lot of drugs, a lot of painkillers being used, a lot of impact on vultures compared to other places. Okay, so you've got this nice spatial variation going on here, which is exploited over time. Okay. All right. Okay, so that's how we measure the vultures. That's the biodiversity side of things. So you've got the diclofenac use, which is at the district level. Now you've got the vultures, so you use range, and this is a sort of so there is some anecdotal kind of citizen science data on vultures, which is not at this kind of same spatial level that you can do any kind of serious analysis with, but like this is the kind of anecdotes of vulture numbers over time. So this is a separate data source to kind of show the kind of story. Yes, it looks like the vultures are in decline. Yeah. Okay, what next? Public health. At the end here, got public health, got mortality data, again recorded at the district level, so it's like infant mortality, who's dying, it's got a total number of deaths, basically. And this is what you see this is the generics here, you've got this red line is area of high suitability, you know, that definition, high cattle, high vulture suitability, and then low, and you see that there's a departure of these kind of, this is just kind of descriptive data, looking at the departure of deaths between the high and the low areas, like mortality rates, okay, over time. All right, so then let's think about the data on the mechanisms here. So you can see this is a decent, you can see how sort of methodical they are about this paper. This is how you get published in the AER, right? You have this nice story, causal story, and you pick apart every single part of it and you say, right, here's my brilliant data on this, here's my crappy data on this, but it's the best we can do, and build the story, and they do a good job. So here they're using like Again, quite good data collection on sort of. Well, I mean, weirdly, they have a livestock census where, in fact, they don't count rats, I don't think, but they do count dogs, stray dogs in the district level, and such like. And then there's infectious diseases. You've got cause of death and other such tests as well, and pollution data as well. Okay. Okay. Yeah. So here's the empirical methods and so on. So they do a different diff type approach here. They think about these places with high vulture suitability compared to low. They compare them over time. You know the story. So they estimate this equation here, which is like the outcome variable. Let's say it's mortality effects. And they have this dummy, they have a sum of different dummy variables, right, for each period of time to see what the impact was of the combination of like time and this high suitability, this kind of post-patent expiry and vulture suitability cattle treatment variable, right? And the sum there is over different parameters at different points in time after the treatment kicks in, okay? So that's mortality effects. They have another way of doing this as well. Instead of having one beta coefficient for every single year, they sum them up together. You've got 1994 to 99 and 2000 to 2005. That sort of just gives you a kind of aggregated sort of treatment effect there. I mean, you've got all of these different fixed effects here, district and rural fixed effects here. You've got delta, which is zonal council and time fixed effects. And you've got, so why would you have zonal times time fixed effects? Why would you do that? Yeah, tell me.
Maybe if there's like a trend in the change in mortality over years, maybe because there's economic development, it goes down, you sort of take this off with that.
Yeah, exactly. So you could have like heterogeneous trends in these different zones, these different council zones, which are to do with policy, which could affect health and other kind of outcome variables in different ways. And if you don't control for that, your treatment could be picking up that difference rather than the actual treatment that you're interested in, right? So they're just handling these different dynamics, which, as you know from thinking about diff in diff, is like super important to get these trends right. So that's basically that kind of idea. Okay, and then last one here, they do an intensity measure as well, right? So this is livestock intensity multiplied by the treatment, and then they see whether or not where you've got more livestock, the treatment is more intensive, okay, and so on. So they do that at rural-urban level as well. They estimate a long difference example, and then they've got all of these fixed effects. Any threats to identification that you can see there? I don't want to go into. Yeah, tell me what you think.
I could say that first, like the sharp approval for generic diclofenac doesn't reflect like actual adoption of the drug. So maybe in the plot that is in the paper, like the effect like starts later.
Yeah.
The second one I can say is that there is not an actual count of the vultures, so it's more like the inference using this the suitability of ecosystem, which doesn't reflect that vultures exist or not exist there. So maybe it could be also spillovers between control and treatment districts.
Okay, cool. All right. Anything else? Right. You've really got a very detailed answer. Thank you. Yeah, tell me.
I think one thing that they mention is that you can't really use the vulture numbers for causal inference, because when people realize that that a species is endangered, then they go looking out more to find remaining specimens.
This is a big problem for citizen science, right? Is that people, firstly, the data is coming from places where people really want to go, and then, people searching for things. And that's why, I guess it's why the BTO data, which has this kind of random kilometer squares, which everyone goes to every year, is a little less suspect, right? But even then, that depends on whether it's raining or not, as to whether people go and all of that sort of thing. So there's a bit of potentially awful noise. But anyhow, on the first point about when the get carried away with this stuff, but like when the patent gets removed. I think, you know, that's the purpose of splitting up this into two parts, I think, isn't it? So that actually the hypothesis here is it's not going to happen. We're not quite clear about how much the adoption takes place in this period. So we're going to split that from this. And indeed, we'll see later on that the results are as you'd expect for a kind of technology adoption type frame. Yeah. But yeah, you know, it's always good to question these things because it's such a beautiful story. The tendency is to go away and go, oh, that's such a beautiful story. It must be true. Yeah. So you've got to keep your guards up, I think. But anyway, it is a beautiful story. So let's crack on. Results. Mortality effects. First equation there, series of different kind of betas at different times, and we see what you were saying before. There's not much happening in the early years after the patent disappears and the generic is approved. Not much effect, but you can see it's going up, and then later on you've got these effects on infant mortality. Yeah.
Sorry, I might have missed it, but what does the H3S stand for?
High vulture suitability. Yeah. Yeah, yeah. Any climbers in the room from England? Right. Because that means hard, very severe. Climbing as well, by the way. Anyhow, yeah, high vulture suitability. All right. So yeah, so you see this kind of this is supposed to be kind of non-parametric estimate of the impact of this thing on infant mortality. I mean, that is pretty incredible, don't you think? You know, you lose some vultures. And next thing you know, you've got an increase in infant mortality in those areas where there's high vulture, where there was at least high vulture suitability. Pretty incredible. All right, so what else did we learn from this? I mean, lots of different kind of controls are put in here. So this is a bit, there's no stars here. So this is another thing you should be aware of is that like the trend for putting stars on things has disappeared. So these are standard errors. So if it's, you know, if you divide one by the other and it's sort of more or less, if it's greater than 2, then you can think, okay, that's doing something at 5%. So you see that they add in different kind of controls here. That's the first model. This is the next two models where they split it up into 2 time segments. And what else do you see there? Yeah, so you see that the effect is slightly higher in the second period than in the first, right? In the average, as we expect. And then what do they do here? In the third model here, they've got some different controls for all these kind of things. Okay, so they're kind of being very careful about these different fixed effects that they use. Now, one thing that is interesting to notice is that once you put in state-by-year fixed effects here, which is in the last model there, to handle those heterogeneous trends, some of the significance kind of disappears up here, right? Particularly in the first few years. Yeah? So that's suggesting that there is something heterogeneous that you were mentioning about, whoever it was that he was mentioning. Yeah. Okay, right. Aggregated time. So here's this is the aggregate effects. These are the kind of 2 separated out effects that we looked at before. Oh, hang on. It's doing its tricks again. And then here's the livestock intensity. So, you know, high livestock intensity, basically you've got sort of 0 effect happening. And again, oh no, sorry about that. You've got this triple diffs kind of approach here. You've got some effects happening here in these first 2 models. But look, when you add in these kind of state-by-year fixed effects, actually the effect disappears here. So this is not emphasized tremendously in patent. Okay. Rural, urban, turns out it's mainly urban. Yeah, question.
Yeah, about the state-by-year fixed effects, maybe I don't think I understand it. Isn't this like a geographical approach? So if we fix for the geography, then it makes sense then.
The state fixed effects would be fixing for something peculiar to the state.
Yeah. And
then it's multiplied by time. So it's I think they did 2 different versions. One was just a linear trend, and the other was like an actual fixed effect for time. So just like a typical 2-way fixed effect, and that handles kind of heterogeneous trends between the states and over time, right? So that seems to be kind of a critical aspect of these results here. Okay. And now they start thinking about the economic cost of keystone species. So for whatever reason, they think that the central application where they get these kind of results is the one that is the best one, right? And these are the kind of numbers that come out of this for establishing the value of these ecosystem services, right? So what do you get? You get 0.48 deaths per 1,000 increase. So that in that period of time, that's over 100,000 extra deaths because of the loss of vultures from the ecosystem. Value of statistical life, hold your nose. Let's just do this. In India, and this is one of the reasons why people hate this as a measure, right? In India, like in America, it's like 12 million quid or something. Yeah, in India, it's $665,000. I mean dollars always. But then you multiply those up. That's nearly 70 billion per annum of lost people, like of increased risk, let's say, of death, right? That you would like to avoid. Yeah, tell me.
But then the value of the statistical life also uses contingent valuation. So even though if we try to use at the end, we still use.
That's a good point. Yeah, that's a good point. It doesn't always, by the way. I mean, the best work on this is by a guy called Kip Viscusi, who's I think is at Harvard School of Health or whatever. He uses labour market data on jobs with different risks and looks at the wages that people get paid to bear different levels of risk of death. Yeah, and you can back out the value of statistical life from that as well. But you're absolutely right that a lot of, and it's a good point, is that a lot of the VSL stuff is done by asking people, okay, you know, this is the amount of people who die from this disease, from this, yeah, let's say this disease, or no, let's say from roads, traffic accidents, and how much are you willing to pay to reduce that just to this amount, you know, some small amount. And from that, you know, you get a marginal effect of reducing a risk by 1%, and then you times that by whatever the willingness to pay is, you times that by 100, and that's the value of statistical life. And yeah, it's dependent on stated preference. Yeah. Good point. Hadn't thought of that before. Yeah. Anyhow, yes, tell me.
Is that total lost value just from lives lost?
So it's not about, I guess it is about
Like,
lives.
is it just about death? It's not about like other costs.
Yeah, you're asking the right questions here. It's sort of, yeah, is it that we've valued every single life that's been lost as $600,000? Or is it that's not what the value of statistical life does? What it tells us is how much we would, it derives from the fact that we'd like to reduce the risk of death by a percentage point. Right.
But it is just the value of statistical life.
It's
that
just
value.
that, yeah. That's 70 billion, yes, yeah, per annum. So that's an asset. If you want to do like asset values, like at the discount rate in India, then that's like $1 trillion of asset values that you've lost there. Yeah, tell me.
Yeah, I guess this is a similar question of like, if there's like health impacts that don't result in death, would that be included in this analysis?
That wouldn't be, no. That's a completely separate thing of morbidity and all of that, which is, yeah. So in the paper, they're using it for kind of, you know, like, look at this. This is what this could mean in dollar terms. Yeah, that's what they're doing. Yeah. So that's big. That's a big value. Like if you think about well, I mean, whether we think this is a really big value or not depends on what the alternatives are, right? And they go through this exercise in the paper where they look at like what capital investment you would need to kind of replace this service, and it's like pretty expensive, right? So the vultures are definitely doing a better job than the capital investment. Yeah.
I was thinking about the external validity of the paper because
Good.
yeah,
Right.
because it's very like specific to the context of India, but like more of that is that we're facing the total extinction of these vultures. It's not like the analysis of what's happening if like one of the keystone species disappears, but in the margin. Yeah, so I don't know like what's the extent of the externality in this paper.
Yeah, it's about loss of a species rather than loss of an individual, right? Isn't it? You know, and that's a really good point right there. Yeah. But it's kind of interesting because when we did the work on, when we looked at innovation and the value of the marginal species, in that context, not very valuable. In this context, because of the situation as a keystone species, potentially very, very valuable. Yeah. There was a question at the back as well. Oh, there were two, I think. Are you?
What's the difference between the value of the statistical life and then the value of lives lost? I mean, in terms of morality and like moral position.
Value of lives lost. I don't know. I'd say I don't know. So in the UK Green Book for cost benefit analysis, they don't use the term value of statistical life. They use the value of an avoided death. Yeah, and that's really what it's about. It's about the willingness to pay to avoid the risk of death. It's not about valuing individuals and so on. Yeah. So I think that's where you're going. Like morally, yeah, it's big problem.
Someone that there's like a new term or something like that that's now being used instead of the term.
Yeah, I think it's equivalent to the value of an avoided death, basically, or you know, that term you used. I can't remember what it was. The value of a lost life or something like that. Yeah, I think they're just sort of reframing because the VSL just needs, it's really bad marketing, right? The value of statistical life, it's really awful, particularly if that varies from one country to another. I'll tell you an anecdote actually about when I was at UCL CSearch, which was like the research outfit on environmental economics. It was run by a guy called David Pearce. I don't know if has anyone heard of David Pearce in this room? Yeah, so has anyone heard of Resources for the Future? You're all nodding your heads. Yeah, so like the US had Resources for the Future. The UK had David Pearce, basically, back in, he was like the most formidable and important environmental economist in the late 80s, 90s, my PhD supervisor. If you ask around, you've got lots like Giles Atkinson, Susanna Morato, Charles Palmer, Ian Bateman over at Exeter, all students of his, right? And he wrote the UNFCCC report on climate change, 1996, and I was doing my master's there at the time. And in that report, he did a value statistical life approach to the value of kind of climate damages in different countries. And of course, the value of statistical life varies from one country to the next, depending on income, which is a really big problem for this measure in some respects. Anyway, next thing you know, there's a group of people from the LSE who are attacking the office at UCL with a video camera and like baseball bats and stuff, and they just come in and start smashing the place up because they disagree with the value of statistical life concept. So yeah, this sort of antipathy hasn't disappeared, I think. Yeah. Last question on this.
Yeah, so no, I was sorry, we're talking about death, so it's gonna not sound great, but can we should look also at the benefits, because if there is an increase in productivity from using the deferral, and then that maybe also improves nutrition and increases actually life expectancy.
Yeah,
so
right. Okay, so
it leads to the equation.
Really good points. Really good points. Yeah. There's a thing in India called the White Revolution, which was all about the revolution in milk production, right? And yeah, that doesn't get talked about much in this paper. So we should be thinking about it in the round. Anyway, really all good points, which I want to discuss more in the seminar actually about this. That's what we're going to focus in on. Yeah. So I'm going to move on. Okay, that was the functions. This is the bats. Spent a bit too much time on the value of statistical life there, but anyhow, it is interesting. So this is the bat story. Everyone know about the bat story? Anyone read this paper about the bats? Yeah, it's a nice one. There's a couple. This is white nose syndrome. Turns out that this kills 90% of bats in a colony if it gets into a colony of bats. It just kind of disorientates them, so they can't use their sonar anymore, I think, amongst other things that it does to them. And it turns out that bats are like really amazing. The ecosystem service that they provide is pest control. They can eat something like 60% of their body weight in insects every day. Right? So they do an amazing job, it turns out, of pest control in agriculture. So these two papers by Manning and Ando and Frank's science paper kind of try to tease out the empirics of that story. Okay. So there's two it's usually the L3 paper that gets cited here, but the original one was really sort of on agriculture, was Manning and Amy Ando, who were in Illinois, I think. So they look at land rental markets and the implications of bat loss on agricultural rentals, rental values. Okay, so they're trying to establish the ecosystem service value via sort of surrogate markets, or just markets. So this is the idea: expansion of the fungus affects the insect-eating bats. This is biological pest control, and then there's like two things that happen there. That's the ecosystem side of things, but then on the agricultural system, of course, farmers are going to respond to this. If they think that if they're seeing that insects are attacking their crops more than usual, they're going to respond with more pesticides. Okay, so either way, that leads to increased costs for them, and this is what they're trying to establish. They look at it in a very kind of linear framework, supply and demand, and they think about shifts and so on. They do this kind of quasi-structural type of estimation. And this is what they do. So they look at the kind of incidence, the map of incidence of white nose syndrome for bats across the US, and they look at the year since this arrival, and they look at changes in the cash rental per acre, and they see that it sort of goes down after a time. Okay, so this is just kind of descriptive diff in diff type analysis there. But then they go a bit further, and they think, okay, let's think about the spillover effects, the direct effect of white nose syndrome in your county, right? So it's yield and it is sort of yield and land use, and also the indirect one. So this second variable here is like a count of counties around you who also have white nose syndrome. Okay, so you're thinking about not just the direct effect, but also the effect of having counties around you on this problem. Okay, so that handles kind of spillovers. A bunch of different controls, the usual kind of fixed effects story here. There's a huge, obviously the assumption here for identifying these effects of white nose syndrome or whatever outcome variable they're interested in depend on the exogenous arrival of this disease in space and time, right? It's nothing to do with the productive activities of the farm. It cannot be. And actually that biologically seems to be the case, right? So it's arrived as a thing. Speculation as to where this came from and why it arrived in the States, but then it spreads in a way which is biological and nothing to do with farming. So the argument goes. In this simple framework, what they think about is a loss of natural capital, right? The key here. This is like your demand for land. This is the supply of land, and this is the value that you get for land. So demand is sort of, it's a profits, rental value that you get from it. Once you lose the natural capital of bats, this brings in your value of marginal product somewhat, and the difference between the two, you can estimate the losses there as this area X of Y. It's basically the difference between the producer and consumer surplus in the first case and the producer and consumer surplus in the second case without the bats. Okay? All right. So it's all linear and like, we just want some analytical forms just so that we can inform our empirical analysis, right? So it's pretty helpful. So we come back to this analysis here. They look at land use and output here, and then they point out that actually, if you've got this linear supply curve, the direct effect and the indirect effect, the ratio of these two things has to be the same for output and for land use, okay? For prices, this is the kind of price of land as well. It has to move along, but in both cases, it has to move along the same line here. So there's a parameter restriction they can bring in, which is the ratio of B0 and B1 is the same as the ratio of theta 0 and theta 1. And that leads you to kind of replace, let's say, theta 1 with another expression, which is beta 1 over beta 0 times theta 0. Okay? So they've got a structural restriction on their regression, which allows them to estimate, given the price response, what the overall impact is and get an estimate of X and Y. Okay? So it's just like really simple, applied theory, attach the problem, let's measure natural capital as a consequence of the bats, and then we can run a regression here which tells us something about these impacts. They find that the direct effect is relatively small compared to the indirect effect. So it's a spillover effect of bat loss, which is causing the biggest effect on profits and land rental, basically. Welfare costs are 2.5. They have to make an assumption about the price elasticity of demand. They don't, they do sensitivity on that, but here it's like 0.35 in this example. So it's quite neat, quite a neat story. Good data on agricultural yields in the US, and they find that there's this kind of welfare cost of 2.5%. This is $15 per acre. Rental value, that's quite a big hit on farmers, because of the loss of this ecosystem service. Okay. So we value things in a kind of nice market-based way. What A.L. Frank does, and it takes it another step further and says, okay, now that let's have a look at how farmers respond to this. Pesticides increase, insecticide increase, and let's see how that affects infant health. And so they do this, he does the same kind of analysis. He finds a much higher effect on agricultural losses, actually, once you start looking at the additional inputs that came in through pesticides and so on. Something like 27 billion, 12% of agricultural GDP. That's absolutely bloody enormous in that part of the US, right? And also infant mortality, value of statistical life, 10 billion, okay? And that's in a, so I found this surprising, but maybe this isn't surprising. So maybe this is like me being, my sort of preconceptions of different countries that I know nothing about. But basically in India, I was thinking, what are the other capital inputs that prevent infant mortality arising from, more carcasses being around? There probably isn't much, right? I would have thought in the US, there would have been systems in place to handle extra pesticide load in water, maybe some treatment, something like that. No, turns out if there is, it's not enough to stop a small increase a small decrease in infant health. This is infant mortality per 1,000 live births, right? This has increased in the USA, where you'd expect things to work properly. If you talk to people from the USA, it turns out that they don't have these kind of preconceived ideas about how great the US is. So, yeah, I've been educated about this by many different people. But actually, you look at this and you think, this is not brilliant evidence, is it? This is in the science paper. There's a spike there, it's noisy. I'm less convinced by that than the vulture story. But anyway, there it is. Big numbers, ecosystem services, loss of keystone species. Okay. Now, the wolves is interesting, but I can do that quickly. There's another paper coming out soon in Science. Now, you can imagine, like economics, what it is at the moment is just this kind of empirical, it's an empirical thing now. Back in the day when I was doing environmental economics in 1995 with David Pearce and his acolytes, it was all like Frank's lectures, just like theory the whole time. There was absolutely no empirical evidence at all. Now there's like loads of it coming out, and you can see this kind of bat experiment is being exploited by everybody now. Oh, exogenous shock to this part of the US from disease, and they're looking at every single possible outcome that could have been exogenously affected by this, and some are good and some are bad. But this is a really good one. So this is Eli Fenischer. He used to work for the White House. He's a brilliant economist, and he's at Yale. He's done like foundational work on natural capital valuation. And anyway, this is an empirical piece. What he does is he uses the bats story again, but instead of looking at agricultural outcomes or whatever it is, he's looking at the cost of borrowing for municipalities, which is basically looking at the price of municipal bonds, right? And he finds that this shock actually affects the cost of borrowing for these municipalities. And if nothing else, he was saying to me, given his experience inside the sort of workings of the US government, who by and large don't, I mean, particularly these days, don't really care about like the environment that much. Let's just say it like that. Yeah. What they do care about are things like tax revenues and borrowing costs. And like if this seems to be an extremely powerful story concerning loss of keystone species. It's not that it's affecting infant mortality. Infant mortality is like very nebulous to like municipalities who are trying to handle budgets and deal with policies across a range of different things. Borrowing costs, how much you can levy in terms of tax, that's really important to them. And he's showing that basically these capabilities are reduced by the fact that these species have disappeared. But of course, that's running through all of the agricultural returns that these municipalities are borrowing on the basis of. They're borrowing on the basis of future returns, which are coming from agriculture. Yeah. Tell me.
Yeah, I think you kind of just said it, but I was wondering what the causal chain is, how we get from that to the borrowing.
I assume it's actually that. So the paper hasn't come out yet. I've just seen one presentation of this about 6 months ago, and so I'm telling you what I know about it. It's coming out in Science though sometime soon. Maybe it's out already. I didn't get a chance to check, but check it out. Watch out for it. Yes, there was another hand somewhere. Yeah. All right. So that's what I wanted to tell you about. Last thing about that, it's quite kind of interesting. This is the wolves, right? Reintroduction of wolves. Anyone from Scandinavia here? This is a story that you'll be familiar with, I think, but this is Canada. I mean, this happens in Norway, in Sweden. I'm not sure about Finland so much, but I imagine my wife is Finnish, and so she's never mentioned it. But this is what's going on. Over time, reintroduction of wolves, right? For whatever reason. I mean, really, it's the idea of pristineness, to make these ecosystems more intact, and there's a lot of ecosystem services that come out of it. And this is what's happened over time in Wisconsin, right? Sorry, it's not Canada, it's Wisconsin. So these are the kind of things that happen. Wolf density goes up, and the measure of benefit here is about vehicle collisions with deer, right? And so you're looking over time at this is the deer density here in treated and untreated, right, places. And these are other vehicle collisions, which are basically the same. So this is like a robustness test here. These are deer vehicle collisions, which have clearly gone down in the treated areas with more wolves and so on. And here's the difference between the two, and these are the error bars here. So basically the story is as follows. You introduce wolves into areas, and the number of collisions with vehicles and deer disappear. It goes down, right? So you're saving lives by doing this, as well as whatever else you're doing. Two aspects of it. There's a behavioural effect and a population effect. One thing is there are fewer deers. The other thing is when there are wolves around, the deer don't hang around by the roads. They're kind of here hiding away in the woods there, I imagine. So they are able, in this paper by Rayner, which is in PNAS, a brilliant paper, they actually separate out these two effects. Okay? So there you've got kind of ecosystem services, empirical evidence, in the context of biodiversity. This is the summary I wanted to say. There is another paper on locusts. I put that at the end. You can check out the slides there. Basically, monitoring locusts, super important. Locusts can affect GDP, it turns out, huge amounts. Through stunting, through education, through development of kids and things like that, because they affect food supply. But the basic conclusion here is that the data on biodiversity is usually pretty terrible, and so you're really forced into like thinking about range maps or keystone species which you know are going to have some kind of non-marginal effect on things. Proxies really is what you're after there. You've got ecological processes which, from an empirical perspective, can be a source of exogenous variation, like the bats or whatever, so that's really helpful for you. But there are sort of other things that you need to be worried about. Measurement error, false negatives, discontinuous responses, and so on, which these papers have tried to handle in some or other way. Right? But the key here is that we've moved away from like those broader diversity type measures, which are important, to let's think about keystone species. And the reason we're doing that is because we want empirical evidence, and marginal changes in diversity really not doing much in terms of our ecosystem services. A loss of a keystone species, that's a catastrophic event, so we're likely to pick that up in an empirical analysis. So that's sort of the evidence that we see published really well in economics. Okay, let's have a break and come back and think about evidence on conservation interventions.
Whether the firm is an ETS firm because the firm's for innovation and because it's the DIT direction, so I have to do the product trend assumption.
Yeah. So what's your control group though?
The ETS firm
Right.
and I actually applied this to...
Is there a scale? Is there a kind of size issue there, or?
I actually applied this to 7 pilots, you know, the ETS pilots.
Yeah.
And I find the listed companies' data.
But what type of firms are part of the ETS, and what type of firms are not part of the ETS? Are they the same kind of firms, or are they different? I know, but like, are they from the same sector even, or are they just very, very different?
Just different sectors. Like the 7 pilots, all the listed companies.
Right.
And I, categorize these 2 parts. It is parallel
So this is your event here, is it?
Yes.
And this is the post-event, yeah, okay.
It is from around this period.
I see.
And the data period is
08. It's very difficult to say, isn't it, whether that's a parallel trend or not. Yes. What happens here with one?
Negative 1 doesn't appear in this table.
Oh, okay. And that's green innovation, right? Okay.
Graph can represent the parallel trend response.
I mean, it's as good as you're going to get. Do you have any data going back further? Time, previous data, like 2000 and between 2005 and 2013. So, like, okay, you got it. Is that the furthest away that you got it?
You keep
Okay, so this is why you haven't got that one period before. That's what it was announced. All right. Yeah, I mean, it's okay, I guess. Yeah. I mean, so because the data is not sufficiently long in time series, you're going to have to work hard on the explanation, like the message. Why is it just in these types of firms are going to be moving together before the ETS comes? I would say it's better than nothing. When I started doing diffs back in like the 2000s, you had two points in time, you know. So it's way better than that. But it's.
And after the policy, it's always
Yeah.
only this.
Right. So I mean, one way, depends what you're controlling for as well, because this is about, I mean, I imagine you've got very simple different diff here with the dummy variable and, yeah. So I think you probably need some more controls in there, which are exogenous.
You mean controls like
Yeah.
These are my controls.
Yeah. I mean, yeah, you may some more control there. I've reduced the variance a bit. I mean, so my big problem with what you're doing is, it's not a massive problem, but it is something, is that the types of firms that are in the ETS are very different from the types of firms that are not in the ETS. They are, like, in the ETS, you've got energy, you've got cement, you've got, outside of the ETS, you've got much smaller firms, different sectors, IT, services, etc. So I'm not sure comparing like with like, in a way. Yeah, I mean, there's heterogeneity within each group, but there's also, these groups are very different, I think. Usually you'd be thinking about treatment and control groups that are basically the same. But they just differ in the fact that one becomes part of the program and one doesn't. We've got two groups which are very different. And then they're very different, and this one. Yeah. So another thing you could do is control the characteristics of these firms, right? So you do like a propensity score type matching, which would precondition the data. So basically, you've only got firms on both sides which are broadly the same in terms of size, in terms of this and that, sectors, and so on. And redo the analysis. That may give you sharper results. At the moment, you've got some very, very different firms. Maybe do some matching between those two.
Yeah, then you can. Then I can send you all the questions before that. Then you can stay for that.
I'm going to talk to this person here now. Yes.
Like in the scheme, I think there's like this red line going between vultures and hooks and rats, but like to like the presence of vultures and species.
I think that, so this is saying, I don't think it's saying increases, is it? I can't see the colour. That's red is decreasing, yeah? It's saying, I think what it's basically saying is that, my understanding is that infecting vultures means more infected bats. I mean, that's, yeah, I don't know what's going on.
Okay, and then, yeah, I have one question here about like
Yeah.
because if in one place the amount of like the kettle, like there's less kettle, then the
Yeah. I mean, that's a reasonable point. The question is, the question is how much does that happen? Yeah. So you have to test it out. I think you could do that empirically and see which are far apart and places which are quite close together. Now that would give you a sense of like global. It's a decent point.
I have like more a general question because like for all these makers, should we know them like intuitively or just like so are we expected to read off them or just know the main from the list? Like how should we approach it?
I mean, for the seminar, it's good to know it quite well. Yeah, it's good to know it quite well.
But like all the papers discussed in the lecture, I don't know which are in the reading list.
Yeah, that was certainly it. There's one for week 8, right? Yeah, I mean, I don't think. Yeah, I think you know them pretty well and understand like why this is a valid result, right? Okay, shall we assemble? Right, in the seminar, it's going to be a bit more of a discursive kind of a seminar, I think, where I want you to think about some of the concepts, the relationship between these kind of ecosystem, these keystone species and natural capital and context that we were talking about before, and so on. And actually, the seminar question also has a question about this. Now, I'm going to skip through this because I want you to just kind of read through this. There's a paper associated with it. I mean, I'm asking you to read a lot, but you know, it's kind of good for you. But I want to just get the basic. In fact, I'm going to give you the basic idea without looking at any of the slides, right? And then you'll see, you'll be able to understand the slides in terms of that later on. Yeah. So with, I wonder with Frank, you've gone through like social cost of carbon and also abatement cost carbon pricing, right? Do you remember doing that? The basic idea. So this is what they do in the UK. Yeah. They basically say, well, we have the Climate Act. We've got a legally defined target for climate change, net zero by 2050. We also need a price for carbon when we're making kind of government decisions, and investment decisions, and doing cost-benefit analysis, right? So what are we going to do? There is some controversy around social cost of carbon, sort of. You know, there's quite wide-ranging estimates. I mean, what's the latest, highest that you've heard in the literature?
200, 250?
200, 250?
800.
Any advance on 800? So the Bilal Kanzig paper, which has just come out in the Quarterly Journal of Economics, I mean, that's sort of its central value is like $1,000 per ton, right? Which is like massive. And yeah, might be true. I don't know. Anyway, there's a fair amount of variation here. The US, before the current administration, was using a value of around $190 per ton of CO2, right? Which is seen as quite high and but like really reflecting the literature and so on. but there's controversy around it, and like the UK government didn't want to do that. And what it did was it said, okay, what is the cost of meeting this target that we have for 2050? And let's look at the abatement costs of hitting that target. And then we're going to use that marginal abatement cost at the point of meeting the target as our accounting price for carbon when we do cost-benefit analysis. We're not going to use the social cost of carbon, which is about the damages and the benefits of reducing. We're going to say, this is our target, what is the cost of meeting that? And use that marginal abatement cost as our shadow price for carbon, okay? So it's a cost-based approach. And one of the reasons to do that is because there's so much controversy around social cost of carbon and a bit of disagreement and so on and so forth. Same is true for biodiversity, right? It's very difficult to value. Contingent valuation, as we discussed already, quite difficult to get our heads around what biodiversity is, how much it relates to this and that policy. It's quite hard. So what we are proposing in this paper, and we've been working with the Treasury on this to try and put this into the Treasury Green Book, which is the guidelines for cost-benefit analysis in the UK, is the abatement cost approach to biodiversity, which is basically say, we have some targets for biodiversity. How much does it cost to meet that target? Let's use the marginal cost of meeting that target as our shadow price for all government investments that affect biodiversity, okay? So that's our proposal, and that's what this paper here on the reading list is sort of going through. It's quite short. It's a nature sustainability kind of paper, so it's sort of very supposed to be quite punchy, which for me it sort of is. My papers generally aren't that punchy, and that's the whole point. All right. So then I want you to discuss that in the seminar as well, right? What is he saying? How can we do that? What is the metric that we should use? Is this a reasonable alternative to actually valuation according to these, these other studies that we've seen? I mean, part of the problem is it's quite difficult to turn this ecosystem value for vultures into a broad shadow price that we can use in cost-benefit analysis in government policy, right? So that's the kind of margin that we're looking at. And that's what all of these slides are about. Yeah, we've done this for abatement cost curve, for extinction risk for Europe. Okay, that's what we've estimated. Based on land use change, based on extinction risk relationships. Okay. All right. So get your head around that. It's not that well, I don't know. Maybe it is difficult to get your head around. It's an idea. Oh yeah, and the other thing about it is that, has anyone mentioned the Envicon conference to you? No? All right, so there's a conference, it's happening at the Royal Society, usually, and I'll get in touch with Sefi about this, usually there's a group of people from this course go to that. Let's see if that can be done. But we're gonna have a big discussion between the kind of contingent valuation people and the cost-based approach people. It's going to be like a slam. So that's what's happening at that conference. It would be good to see. Right. This is what I want to talk about really in this part. So causal evidence on policy intervention. We look at protected areas, payments for ecosystem services, and then a bit on the voluntary carbon market if we get time, but maybe you've had enough of that by then. So, we have only a few levers we can pull when it comes to biodiversity and habitat conservation. And one of those very, very common interventions is protected areas, or different descriptions of national parks or stuff like that. These area-based policies which governments put in place and cordon off, essentially, in principle, cordon off particular areas of, say, tropical rainforest or desert or whatever it is, in order to conserve that area from whatever it might be. Deforestation, mining concessions, we're going to keep this area the way it is. That's a protected area. So there's a big question as to how effective they are, right? This seems to be like a very common strategy. Most countries have protected areas or national parks or whatever it is. And we need to evaluate them. But there are lots of empirical kind of problems that we encounter when it comes to evaluating how good, how successful these policies are, right? So of course, I mean, so I'm saying selection, spillovers, leakage, etc. What possible selection issue could there be with a protected area? Yeah.
You protect the ones that are pristine. You wouldn't protect something that is actually in need of being protected because it's endangered.
Yeah. Okay.
Or critical state.
Yeah. I mean, that's probably, that could be true. Yeah. Tell me.
You could select the ones which are already unproductive for agriculture or other ones, so probably wouldn't have been touched anyways.
Yeah. Could be. Any other points on the selection issues that we might have? Like low risk. Governments don't want to fight typically. Yeah, tell me.
Yeah, there could be like very specific interest groups that try to influence the government to then select specific areas to protect.
Yeah, could be. So we've got all of these different things that mean that the protected areas that we see are not randomly assigned in the ecosystem space, right? And so comparing those to protected areas to non-protected areas becomes a really tricky kind of business. To see whether or not they're selected. Because I mean, if you just did a straight comparison between, there's a tendency to do paper parks, parks, protected areas, national parks, which are kind of out there on the tops of mountains, and they were never ever going to be depleted anyway. So, and then you compare that and let's say forest cover with some other area, well, it always looks better, right? Because it's pristine, as you were saying. Low risk, pristine, etc. So this location bias is something that we have to handle as we go through. Yeah, spillovers happen as well, right? So once we put in a protected area in one place, this can mean that the activities that were there spill over just adjacent to it, and then so you compare next door to the protected area. This looks much worse. This looks better. You think, oh, we've done a really great job, but actually all that's happened is you've displaced activity already. So that's an empirical problem. Economic problem as well. Leakage, I mean, leakage could happen. Imagine that you had the whole of Indonesia became a very effective protected area and palm oil had to just disappear from Indonesia. What do you think would happen then? Well, there'd be some kind of international response there. You'd quite quickly see palm oil popping up in West Asia, Central Africa, and the tropical forests in Africa and so on. So there is like leakage as well, right? Yeah.
Would then illicit behavior like still planting palm oil in Indonesia also be counted as leakage?
Sure. You would see that as a kind of spillover. So that's a kind of, yeah, I mean, it's a bit kind of vague terms, but I see leakage as kind of trade effects and spillovers on effects. So, yeah. Anyhow, so there's also heterogeneity in the treatments, there's trade-offs, big impact where risk. Oh yeah, there's trade-offs as well, right? So, if you try and do something effective, you're going to be getting in the way of agricultural activities, right? Where so it's high risk areas, the places that need to be protected because they're at high risk. There's a trade-off between approaching that and maybe paying more money or having to enforce more carefully, and the efficacy of the policy, right? Yeah, you've got two hands here. I am going to have to kind of get skipping through, but let's hear these points.
No, we can. No, it's fine. It's fine. I can add.
Yeah. Okay. Cool. Sorry about that. All right. So broadly speaking, this is an issue of additionality, right? What is the additional effect of a protected area? So here's a paper which tries to handle this in a kind of tries to identify this, and you're going to tell me why it's wrong, but like it's still quite a neat paper. This is Sarah Meyer, one of my postdocs. And it's together with Ben Boundford and Villa Inken at Exeter. So we had this project in Bolivia. This is Bolivia, and this is like from 1985 through to about 2020, 2022, something like that, and 2021 in this diagram. And the orange here is basically agriculture. So like in Bolivia in 1985, there was basically it was just forest. And this is Santa Cruz, right in the middle. Does anyone know this area particularly well? Yeah. So this is like the center of all activity is Santa Cruz. And it just explodes this agricultural activity into the kind of There's two types of forest here. There's sort of moist forest up here, and there's the chaco, which is like a dry forest down here, which is sort of low-level dry forest. You know. Right, and then you see these areas here. These kind of like these are protected areas coming in over time, right? So there's some that there already, and they're like way out in the, you know, these original protected areas in 1985. These were in place in like 1965 or something like that, and they're just way out there. Yeah, let's protect that area over there. Maybe this one here. And you can see there's a sort of a range of different responses in terms of protected areas. There's sort of let's protect these areas which aren't really under much risk at all. And also, and this is Cayuni. This is called Cayuni, this protected area here. I think you got that right. And I mean, this one seems to be sort of getting in harm's way, right? And sort of being placed where there's like high risk of agricultural deforestation here, pushing things out. The story with that though is that these are communal areas which then had another layer of protection put on top of them already. So it may not have been causal, that particular thing. Anyhow, you see how this works over time. There's a bit of a dance taking place between protected areas and agricultural development and policy, and there's trends and all sorts of things. So anyway, the key problem here is that some protected areas are in areas of low risk, and others are in areas of really high risk, particularly these ones that come in here, these little ones that come in here, they're in like really high risk areas. And so comparing high-risk areas and low-risk areas, it's not going to give you a very decent explanation of how well a protected area worked. And indeed, one would expect the protected areas that are well enforced and put in harm's way in areas of high risk to give you a better treatment effect than those which are up here in low-risk areas, which just, you know, if they weren't there, the forest would still be there anyway, right? So they have very low additionality. So in this paper, what they tried to do is basically match up these different protected areas and different pixels on the basis of the risk of deforestation. So they do a machine learning map of Bolivia to try and understand, so they do predictions of deforestation risk based on kind of geographical features and distance to roads and all of those kind of things that determine deforestation. And then they basically match on these risk parameters. So they match up areas with and without protected areas on the basis of having the same level of deforestation risk. And that's how they evaluate whether or not a protected area was effective or not. They also match on basically biomes here, so they choose pixels within similar biomes as well in order to do the comparisons. That's like controlling for all of the observable stuff in the background. So then they do that, and basically what they find is, you know, if you go through time, this is the kind of typical kind of event analysis there. We've got a lot of data going back 30 years, right, until for this particular exercise. You've got this kind of loosely parallel trend here, and then what you see is that, you know, with some duration, you've got positive effect of the protected areas when you've matched on the basis of risk. So this is kind of controlling for the location bias, because you've got protected areas in the places being matched with areas which have similar levels of risk, right? And when you look at, you can't quite see this actually, it's a little bit small, the dots here, but basically on the x-axis here, you've got risk quintiles, levels of risk, so high risk at one end, low risk at the other, right? And what you see is that from this work that they've done is that the areas which are very low risk have low additionality, of zero effect. Yeah? So those protected areas, pixels which were up in the north there where there was very low risk, they're having zero effect of additionality. Where you match things up and there's much higher risk, then you're seeing a bigger effect of protected areas, right? And that sort of, to some extent, makes sense, right? So it's a neat application which tries to handle this location bias. Different types of protected area as well, and so some do better than others, basically. Okay, so so that's one way of thinking about the location bias and getting the effect of protected areas. Now, with protected areas, there are a bunch of different other problems in terms of implementation, of course. So There's also the impact on local communities. It's fences and fines story. It doesn't seem particularly fair. I mean, think about apartheid South Africa. Back in the day, people were basically kicked out of their land, protected areas, national parks set up. Pretty unfair stuff. That kind of thing sort of still happens. People get kicked out of their land, basically. Stuff that they had open access to, communal rights to, gets changed. So that's an issue with protected areas, even though they may well be effective. You've got spillovers to the locality, as we talked about before. You've got leakage regionally, and there are monitoring and enforcement issues as well. So, in terms of solutions, this is a brilliant paper, by the way, by Matthias Reinhardt. It's on the reading list. It's a kind of summary of all the work that's been done on protected areas by sort of environmental economists, empirical work. Really, really good. So sometimes what happens is you have a protected area in place and it has a buffer zone, buffer development zones, around this area, next to the protected area, you can do a certain amount, or rather within the protected area, in this buffer, you can do a certain amount of whatever it is you were doing before. It could be agriculture, it can be non-forest timber products, it can be whatever. So this is one kind of solution. Or you get community management, or sometimes you get money. And so another kind of approach here is thinking about the effectiveness of monitoring and enforcement in the context of protected areas. We're going to talk about payments for ecosystem services in a minute, so that's where the money comes in, because of course protected areas typically it's involuntary and people don't get any money for being pushed out. So anyhow, here's some causal evidence on monitoring enforcement and how effective that can be for monitoring forest protected area. Or this is kind of another policy, really. Looking at the blacklist in Brazil. So what happened in Brazil was that in the 90s and 2000s, there were areas which were designated sort of protected areas, but the monitoring was really difficult. So you'd have kind of people flying over and looking and maybe excursions, but of course the areas are so enormous, you just cannot handle it. So it was really not very effective. So what happened in the early 2000s was this action plan came in, they introduced a deter system. This is basically them using satellite data to look at forest cover, and then any change in deforestation alarm bells would ring, and then they would send someone to that place and say, "Yeah, listen, come on, you're breaking the rules," and prison sentences and fines and stuff like that, right? This turned out to be very, very effective. Right? The technological advance of having satellite data to monitor protected areas was huge, right? Really helpful. Phase 2 of this action plan did some blacklisting of municipalities, right? So you got this is like a disclosure type mechanism, really. You blacklist municipalities who are doing particularly badly on deforestation, yeah? And there were 3 categories, but these are the most important ones, like the total deforested area. So if your municipality had a large total deforested area, you're on the blacklist, okay? And you'd have extra monitoring and certain things would come in and, it was basically costly for you as a municipality. And then also like total deforestation over the past 3 years. So it's like a trend. How bad your trend is in the past 3 years, that can get you on the blacklist as well. And these are the blacklisted municipalities right here, okay? So this paper by Assunção et al. Review of Economics and Statistics, a really beautiful paper. Should sound like Trump. It's a really beautiful paper. They basically try and handle how effective was this blacklisting approach. Not only that, how can we learn from this in order to say, well, is there a better configuration of protected areas and blacklisted areas that could get us more carbon sequestered, less deforestation, and lower costs? So they do, it's a bit complicated what they do, but they look at, this is kind of just broad data here, this is deforestation here. This is the first phase, this is the second phase where the blacklist comes in. And these are kind of non-blacklisted areas there. So there seems to be something going on, right? This first phase of monitoring was really, really effective, and the second phase, well, let's see. So they have these priority list areas, and they have protected area, priority list areas in the black here, and they've got a bunch of protected areas in this kind of shaded map here as well. And in order to understand, like, the efficacy of this whole thing, they use a very kind of interesting method. The key thing was that the areas that were selected into the blacklist were selected on those two categories, you know, deforestation and deforestation in the past 3 years. And so that meant that those in and those out of this program are very, very different, right? And so basically matching doesn't really work because you've got no overlap in these characteristics. It's very quite clean kind of separation. Regression discontinuity is not possible either because you've got hardly any which are right next to each other, right? And then you can't use it instrumental variables either in this context, mainly because of like this very slow process of deforestation means you've got autocorrelation of the error terms, and that means that any lagged kind of instrumental variable just doesn't really work. Okay. So what they do is the following. They do a changes and changes approach, which is a diff in diff type approach, but not for the mean, for the entire distribution of outcomes. Okay. And this allows them to do some incredible optimal design for protected areas and policy, effectively. So let me just explain how they do this. So this is a diff for the entire distribution. It allows you to handle heterogeneous effects across all of these different areas. And it allows you to estimate not just the average treatment for the treated, which is a typical treatment estimation for diff, but also the average treatment on the untreated. So the first one tells you if you're treated, how better off are you than how you would have been. And the second one, the average treatment for the untreated is, you know, for the untreated group, what would have happened to them if they had been treated? So you get the entire kind of distribution of effects there. And the way this works is as follows. It's kind of interesting. So the blue one here is the control group, and you can imagine a distribution of possible outcomes. This is just a kind of stylized example to let you know how this method works. So the blue stuff is the control group, and you've got the before and after. So the dotted line, the dashed line here is time 0, and the solid line is time 1. So you're sort of saying that the control group, what happens is it had this distribution before, and now it has this distribution afterwards, untreated, right? And then for the treated group, you say, okay, this is the distribution at time 0, this dashed one here. This is what their distribution looked like, and this is a counterfactual. What you assume is basically the same kind of distributional shift happened for the treated group as happened for the untreated group. So this gives you a counterfactual distribution of outcomes, right? That's what would have happened to the treated group had they not been treated, this entire distribution. So you can compare that to what you actually observe, which is this dark line here, which is the distribution of outcomes in the observed data, and then build up treatment effects at every single point of the distribution. So here, this is the 25th quartile, the first quartile effect here. You look at the quartile on the empirical distribution, you compare it to the quartile in the counterfactual distribution. That's what happened at this particular quartile of the distribution. Yeah? If you look at the median at the middle there, you can say, okay, this is what happened to them. This is what would have happened to them. The difference between the two is the impact on the median, and so on and so forth, across the entire distribution. You can do the same for the untreated group. You can build up a counterfactual for them, what would have happened to them had they have been treated, and you can understand the entire landscape of effects of implementing this particular policy. Okay? And once you've got the entire landscape of effects, you can say, okay, this is what the policy looked like. What if we had the policy like this? What would have been our effect? Or maybe like this, what would have been the effect? And you can think about optimal land-based policy in terms of protected areas. Yeah.
So like, you've seen like observables to model and infer the counterfactual, but it's just like based on observables, right? Yeah. Okay.
Yeah. But along the entire distribution, that's the kind of key insight of this particular method. With diff in diff, it's just you're looking at the average effect, right? You don't really care what happens in the tails of the distribution or whatever. Here, you're looking at the entire distribution. Yeah.
Do we know what created the increased volatility in outcomes?
This is just an example.
Oh,
Right?
okay.
Yeah, so it's not real data. This is just to tell you how the method works. Okay, so they do this and they estimate these average treatment effect, the average treatment on the untreated. They look at the spillovers, right? So what happens to the places just next to the treated areas, and so on. So you get the full range of different effects there, and they find that it's sort of the blacklisting approach was pretty successful, actually. Yeah, so pretty successful. But if you look at these different effects here, the ATT was pretty high. The average treatment on the untreated was a lot smaller, but still kind of important. And this is the average treatment on the spillover effects as well. Then you've got the carbon effect and all of that. Okay, yeah.
Why is it a range and not a single point?
Say again?
Why is it a range, the effects is a range and not a single point if we know the whole distribution?
These are just like summary effects, yeah. Summaries of the distribution, but for different groups, right? So these are average treatment, average treated on the untreated, and then the spillover group, and then this is the entire average over across all the distribution, yeah. We could have quantiles if we wanted, right? I've just chosen to do averages over different groups, or they did rather, not me. What this allows you to do is think about like optimal targeting. So this is where the priority list and the protected areas were. This is where, if you had a limited area that you could allocate to blacklisted protected areas, you would allocate in a slightly different place in order to optimize your effect. And then this one here is where, if you had a limited number of municipalities, so you could only do like, let's say 20 municipalities, which ones would you choose? You choose these black areas here. Okay. So you only know this because you know the effect basically for the treated and what the effect would have been for the untreated as well. So you've got this, you can optimize over this. And with the spillovers as well, you introduce this into different kind of spatial configuration as well, with the land, the total area constraint, and the spillover constraint, the municipalities constraint. So what they're doing here is basically saying, look, you could do a lot better with your area-based policies if you undertake this evaluation seriously and think about the entire distribution, what would happen to the untreated, etc. Okay, so summary was, you need the methods to suit the problem. That was all the identification problem there. Blacklist was pretty successful. You've got some optimal targeting that you can do as a consequence of knowing all of those spatial treatment effects. All right, let's think about payments for ecosystem services now. So we've just been thinking about kind of these regulatory frameworks, protected areas. We put it here, everyone gets out, we enforce satellites or whatever, we blacklist municipalities, and we issue fines and send people to prison. What about paying people to do this kind of thing? Well, there's a huge literature, of course, on payments for ecosystem services. So we implement contracts, we pay people to do certain things in particular areas. There's loads of examples from history here. I mean, the classic one was in Costa Rica, the Arenal water shed, where there was upstream people from downstream who used the water, paid the people upstream not to deforest so they could keep the quality of their water. That's a payment for ecosystem services. Service there. There's even like in New York they did this as well, the Catskills. Yeah, instead of building new water quality treatment works, they basically paid farmers not to use so much fertilizer in the Catskills. This is for New York, right? So these are kind of payments from people, from beneficiaries to providers. And with forests, of course, this happens a lot, of course. It's a lot of tropical forest evidence there. In the context of tropical forests, of course, you've always got these development type questions as well. So like if we start paying people to change their, to reforest or to not deforest or to do whatever, do we also reduce poverty in some way, right? So you've got this dual environment development kind of question here, which a lot of the research that I'm just going to cite in a second, it was basically looking at. And the key question is like, do they work at all payments for ecosystem services? And B, do they do this win-win situation? Do give us this win-win environment and reduce poverty outcome? And yeah, there's some theory here which sort of says no, and then my paper with Charlie says maybe, and then there's the empirics, it's pretty mixed and sketchy and so on. Partly because like the causal work on this really only got started in the late sort of 2000s. You know, before that, people weren't doing the analysis really properly. Okay. So here's some examples like. Robolino paper, that's not on the reading list, but there's a link just there, but basically this is quite a recent one, it's looking in Costa Rica, trade-off between poverty and environment. Actually, poverty goes up for the people who are part of the payments for ecosystem services, where you have really effective environmental impacts, right? So it's not just a trade-off, it's a really stark trade-off, let's put it that way. Sims and Alex Garcia, you know, the PES are better than PAs in Mexico. They offer a small poverty effect, and then you know, they're better designed, so you're actually paying people rather than just enforcing them to get out of a particular area. You've got, I did some work in China, so the sloping lands conversion program is the biggest PES scheme ever, probably, where farmers across China were basically paid to reforest massive areas, like millions and millions of hectares of forests, basically because there was a realization, there were a couple of things going on, but there was a realization that deforestation in the upper reaches of the Yangtze River was really causing huge turbidity, like muddy sedimentation of water, ruining kind of fisheries, blocking up hydroelectric dams, and causing kind of flooding and such like that. So they started doing kind of reforestation there, massive. What we found in that paper was that the big effect on people was really, in terms of poverty, was to get them out of farming and off into off-farm labour, either a local village or migrating to rural urban areas. So that has an effect there. These guys in I think this is Guatemala. Is it? Yeah, I think it is. They find that the longer you're in these PES schemes, the better it is, the more effective it is, both in terms of like efficacy on environment and so on, but it's only really successful in those high-risk areas, a bit like the protected areas before. And now, Alex Garcia in the next paper, it looks at a really interesting PES scheme in Mexico. So we're going to look at that right now. What they did was this is the payments for ecosystem services. People enrolled coming on private land into sort of reforestation type schemes. They're monitored by satellite. They got $130 per annum per capita. And their question really was like, how well did this was this targeted? How well did people do in terms of improved consumption and poverty outcomes and so forth? And then also, what was the environmental outcome? So they're really interested in that trade-off between environment and development. You had a question quickly there.
I was just going to say, how do they decide how much money that they're paying? Is there like a uniform way?
Yeah, typically that's. I mean, like to implement programs like this, it's if you start having kind of differentiated payments, you end up with really terrible adverse selection type problems or difficulties in deciding who gets what. So typically, it's just like set a flat fee and off you go. If you want to be in, you're in. If you're not, you're not.
And like, how do they decide what?
How do they decide? Well, I guess it's sort of. So in this case, it's sort of contextual. So you're looking at like the extent to which the opportunity. So you're thinking about efficacy and opportunity cost of land, and whether or not this amount of money is going to change people's behaviour in any way, right? But that becomes, we'll see in a second, that becomes super important in terms of understanding the efficacy of this program. Like where and who do you target and how much It's going to be super important. Okay, so they looked at this match sample, fixed effects design, controlling for all these characteristics and so on, and these are the different kind of payments for ecosystem services schemes that emerged in Mexico during this period of time. And you can see there's a lot of them. You know, they came in 2004 through to 2009, lots of different schemes, amazing kind of data. The Mexican government has been historically very good at this kind of very interesting payments rolled out across nationally across the country. And so it's a really amazing data set that they look at. Okay, results here. So we're interested in the beneficiary area, beneficiary line here. And these are just different empirical models. And these are their treatment effects here. Right? So you can see this is the outcome variable here is percentage forest cover change for the participants, right? The beneficiary of this particular payment. And they do pretty well, right? I mean, in a sense, I can't tell you anything about the magnitude of this, but this is a significant positive effect on forest cover change, okay? This area rejected being insignificant tells you that, you know, that in the selection process for areas that were going to be enrolled, they sort of said, well, these areas can be enrolled and these areas can't because they're already fine, right? And the fact that you can include that as a control variable and it doesn't, it's not significant, tells you that you don't get a payment just for being selected for being selected to be in the program, right? So there's no effect from just being selected in the program. It has to be kind of eligible. Okay. All right, and then if you do this by years paid, you see there's a positive effect. So the longer you're in, the bigger the effect is. Okay, so that's your environment effect here in Mexico. A positive outcome, increased forest cover as a consequence of this being paid to do this. What happens to other things? Right? This is on page 22. This is socioeconomic analysis. This is looking at consumption. So they're looking at food index, durables, housing index, right? Different households, common property, private property households here. And different, you know, you can split this up by tenure class as well, but look, here's the basic thing here, that nothing much is happening in terms of these individual consumption levels. So these would be things that you would expect to be going up because people are receiving payments to be part of this program. You'd expect them to be spending this money and some of these consumption indices to be going up, right? If you look at poverty, well, you see some kind of negative effects going on. This is measured as a poverty index of sort of a bit like the Human Development Index, where you have sort of education outcome, investments, you have health, you have a bunch of things crammed together in an index, and that seems to be improved in some way. So that kind of poverty measure goes down, so there's something going on. So what have you got? You've got kind of some positive effect of on the environment, some negative effect on the poverty index, and zero effect on any of the kind of consumption outcomes there. Right? And in fact, these measures, in terms of the standard deviation change in poverty, is extremely small, right? It's an extremely small effect. So you're getting a lot of environment, not very much poverty change, nothing in terms of investment and consumption type responses here. Okay. So that is problematic in some respects. The conclusion here is that, you know, why don't you see big increases in consumption level and like consumer durables here from participating in this program? Mainly what they find is that this is because, you know, the costs of implementation for people are very high. You see a lot of more investment in fire management and pest management and things like this to be part of this environmental scheme. And so you don't see that's very costly to people, so you don't see increases in the consumption, the standard consumption metrics there. So there's a cost of participating and doing the jobs that you're supposed to do in order to get the money here. There's another thing here, which is a risk of additionality and risk additionality trade-off. As we were saying before, if you target places where there's very low risk, you don't get very much in terms of an outcome. And that, they say, is another kind of a problem that's going on. So there's the kind of environment, PES, poverty trade-off encapsulated in this model, in this empirical work. And actually, they have this really nice bit at the end where they sort of say, okay, what could be going on here theoretically with this particular case? And I think it's kind of interesting to walk through this. So this is basically thinking about, this is some quality of land on the x-axis here, and these are kind of money rents on the y-axis here, right? And what you've got is these two different, so focusing on these zeros first, right? You've got agriculture here, these are agricultural returns, and as you move into the margin of land, let's say this is sloped, this quality of land here, as things get more and more sloped, at some point, agriculture becomes less productive than forest, and you take over and do forest instead. Right? So you've got different people doing different things at different points in the landscape